Val, if I write over here, can you see me?
Yeah, a little bit. I can. Yeah.
Lighting makes it hard to see.
So if we look, let's pick caster for now. The caster spec, what is the perfect number?
2 degrees and 46
degrees.
minutes.
And 46 minutes. So that's not 2.46. That's basically like 2 3/4. But exactly what that means doesn't really matter. What you need to do from there, you want to draw the line, right? The number line. 2 and 46 is right in the middle. And then what's the, we may call it like the tolerance. What's that really mean?
How much of it moves?
Right. So if you were, let's say, shooting a non-lethal weapon of a sort, like a airsoft gun, for example, because that's approved. If they give you a target, the bullseye's right here, right? But then the tolerance is basically how big the target is. So this target is right here, but you can go 45 minutes this way and you can go 45 minutes this way, and as long as you're in the target, it's still a hit. Make sense? That's pretty much what you could visualize. So if it's 2 minutes and 46, but then we're saying there's a tolerance of 45, to go down, that means we got to go minus, but minus how much? 45. So what's that number? 2 minutes, 2 degrees, and how many minutes?
1 minute.
And 0, 1 minutes, right? And then what if we had to go up? What's up? 46, then it gets a little tricky, doesn't it? Then you're like, I hate math, math sucks. So you say, okay, if I've got 46 minutes plus another 45, what would you come up with? 80, 91? 91 minutes is not a thing.
Yeah, that's right.
Make sense? So now you got to think of it as like time. So it's 2:46, and then you go, and if it's 2:46 in the afternoon and you go another 45 minutes, oh, what time is it?
31.
So, well, actually, to be honest with you, I have to really think about this. So how do we do this? I would go like 46. And the way I would probably think about it is we got to go another 45. But I would probably, we could do that. You could do the math like this, right? We go, this would be a 1, carry the 1, that's a 5, 6, 7, 8, 9. That's 91 minutes. And then you're sort of like, then you'd have to divide that by 60. But probably the way I would do it would be quite a bit different in reality. I'd say 46 minutes plus 45. So how many minutes to get to the next hour? So that's only 14, right? So I'd say probably like 45 minus 14 would give us how much?
31. 31.
31. So we know that we're going to be, we go from 2 to 3. And I'm sure there's an easier way to do this, to be honest with you, but I don't teach math. And I'm just saying, you give me any question and I'll have a way to think about it, but on a question like this, I'd probably flag this one and go to a bunch of easy ones and then come back and be like, okay, use all of your brain power on this one stupid question. But I'd still get it. So if we took that 14 minutes and we threw it up here, now it's 3 o'clock, right? So that would be 3 degrees, but we still have another 31 minutes left over, right? So wouldn't it be 3 degrees and 31 minutes?
Yeah.
Right? Mathematically, how you want to do that, I really don't know. I would think about it in time and just be like, it's 2:46. In 14 minutes, it's 3 o'clock, but there's still 31 minutes left over, so I'm coming up with a 3 o'clock and 31 minutes, or 3 degrees and 31 minutes. So now we have our whole range, right? 2.01, 2.0, or 2 degrees and 1 minute, cool? To what? 3 degrees and 31 minutes. Do we agree? You understand how we did that?
Yeah.
Do you like minutes and seconds, or would you rather just do decimal point? I'd rather do decimal points, but it doesn't matter what you want. ASE can do it one way or the other way. It doesn't matter. You got to be able to do it this way. Now, if we look back up here, then that was just for caster. So if we look at our caster, is it in spec or not? Is it? Because we're between 2, let's just call it 201
Okay.
and 331. What you got there on the left caster?
It's out of space.
Okay, It's out. But what's the question about again?
It's not driving straight. I mean,
Okay, so if it's not driving, it could drive straight, so we need to know if it's going to pull or not. So you could, first off, if you want, you could skip a lot of this math, to be quite honest with you, and just say, wait a minute, what's the question all about? Don't jump to the numbers like I did. So gave you a bad sample here. If I just look at the 146 and the 246, I go like this, right? Here's your Val. I'll come where you need to tell me. This good? All right. If I'm like this, what's the left side? 146. What's the right side? 246. Handlebars. Which way is the car pulling?
Left.
To the left. But like by how much? What's the difference from left to right? A whole degree is too much. You know, you have to have the basic knowledge of alignments. We're allowed typically like a half a degree. Half a degree difference side to side. If it's less than that, we're probably good. If it's more than that, we're probably no good. That's really nowhere on here, by the way. It's not giving you your cross caster specs. So first things first, you can do that all the math, and then what I can identify as the left caster is out of spec, and the right caster is in spec or out of spec.
Inspect.
The right caster is great. So the right caster is great, the left caster is bad. Is that wearing my tires?
No.
No, because it's caster. Yes, it's out of spec, but caster doesn't cause tire wear, whether it's in spec or out of spec or any spec, doesn't really matter. It's just the placement of it. Caster will cause a pull. And so they gave you a number here that's out of spec, but see, caster being out of spec doesn't cause a pull. Cross caster being out of spec does cause a pull. See what I'm saying? So if you have 146 and 246, the difference between those two is 1 full degree. That's out of spec right there. And technically, you didn't even really have to do all this math. But you still need to know how to do the math for any question they throw at you. See what I'm saying? So if we were saying the vehicle could drive straight. Well, so far I'm going to say no. But what else could cause a pull? Camber. So now we need to look at the camber. And we could do the complicated math, and we will, but just real quick, look at the camber. What's the camber say? Negative, let's say 43 and positive 43. So now you're going to do that. Left is, we'll do it from my perspective, negative is which way? Hello flush. Right is positive, which is which way? Okay, so where's that going to pull? To the right. So then I'll probably actually make notes on here, and I'll just say camber. The difference between the two is how much? 1 degree. 1 degree to the right, because I just proved it's going to pull to the right. And then the caster was what now?
1 degree to the left.
Oh, the caster's. So wait a minute. You got 1 degree to the right and 1 degree to the left.
Cancel out.
They may actually cancel out. Now I'm going to take this up a notch. On the ASE, they won't really make a stance on this, because it's not totally agreed upon. But in hunter alignment training, they do specify that typically caster has a little bit more power, you may say, than camber. So if you have 1 degree of caster left and 1 degree of camber right, the car's actually probably going to pull left slightly. But that's not universally agreed upon. So you just say, well, those are pretty much going to cancel each other out. So may the car drive straight? It might. So what can we eliminate? We can eliminate B only, and we can eliminate neither, right? So you at least just took this question to a 50-50. Remember, you're trying to get points, so let's get the points. The next one says, the vehicle may experience tire wear due to the camber settings. They gave you this one. See, I would have just said camber wear. I would have just said tire wear. Wouldn't have said camber. You've been like, oh, the caster is out of spec. And it is. We proved that mathematically. But the caster doesn't cause tire wear anyway, so we don't really care. We did need to do the math to figure out if it pulls, right? So let's just pretend that camber wears out of it. I wouldn't necessarily even look at caster because we're talking tire wear. I don't care about caster. If all the customers worry about is tire wear, don't even look at the caster. We don't care. Now we say camber. Okay. Well, I can already give you an idea that probably this is going to cause tire wear, but let's be more thorough than that. The spec, 43. Okay. New number line. New number line. New number line. And if they give it to you in decimals, this is even easier problem, right? So you should be able to really do this in decimals. Now, can you see the red good if I write in red?
Yes.
Red's so
Yeah, red
beautiful.
more good. Yeah.
The spec is what?
Negative.
Negative 43 minutes. So don't forget the negative. Negative 43 minutes. And the tolerance, this is once again fairly tolerance, where we tolerate everyone, it's very inclusive. 45 minutes worth of inclusiveness. In other words, that's a fairly large target. Make sense? The bigger the tolerance is, the bullseye is the bullseye. The bullseye is perfect. If you're an airsoft sniper, you're hitting the bullseye, you don't really care about the tolerance. But if you're kind of like a little sloppy, the bigger tolerance is a bigger target. 45 is a fairly large target. That's 3/4 of a degree. So if we're at 43 minutes, but we're negative 43 minutes, I think let's start with the minus. So what is 40 minus 43? And then you're kind of like minus 45. Who knows how to do this math right here?
Negative 88.
And you're right. But if you do 43 minus 45, you're going to be like 3 minus 5. You're going to be like, oh, that's a 0.02. That's wrong, and that's why we do it on the number line. A 0.02 would be over here. We're going this direction. Your bullseye's in the middle. Your tolerance has to spread out both ways. So that's why I kind of think about it like this. If it's a negative number, if you're $43 in debt, and you spend another $45, you don't have $2. If you do, let me know what type of math you know, okay? Because the more, you don't save money by spending money, despite what the credit card reward says, okay? You understand? You don't go shopping and be like, oh, look at all the money I saved. Saving money means you didn't spend it. You understand that, right? So here we are, 43 in debt. We add another 45 in debt, so the numbers get added, right? Again, I don't teach math. Math would be like, well, it's a negative number, and you're doing a minus. They probably have some way of explaining this. I make it really simple because I'm not that smart. So I say 43 minus, negative 43 minus another 45. That means I'm really adding. So you could add them, right? You could come with an 88. But see, there's only 60 minutes in a degree. So now we're sort of like, okay, if I have 88 minutes, how many hours in minutes is that? So 60 minutes is 1 hour, right? That's kind of like a degree.
So 28.
So I'd say 1, and it'd be 88 minus 60. So that would be
28.
8. Yeah, 28. So I have 1 degree and 28. 1 degree and 28 minutes, right? That's what this number is. 1 degree, 28 minutes. Thank you, because that's how debt works. Yeah. Now, on the positive, you had $43 in debt. You went to work for 1 denarius, that's 1 day's worth of labor till we came up with big government inflation, and now you don't really know what you make per day because it's constantly changing. So you have $43 in debt, you go to work and you make $45. How much do you have?
$2.
That's it. So I wouldn't even do the long math. I would just say, all right, you're 43 in debt, you make 45. I would just go with this right here. It's going to be 0 degrees and 2 minutes. There's your whole spec right now. You can write it however you want. You can do a negative 1 degree and 28 minutes to a 0 degrees and 0.2 minutes. Is it in spec or out of spec? So we're looking at camber now, right? We can go to negative 43. Is that in tolerance?
Yes.
Is that within 1 and 28?
Yes.
Yes. What about on the other side?
No, it's out of spec.
The camber on the right side, 43 minutes, is that within this? No. So the camber's out of spec. You know if it's out of spec, there's a problem, right? So they're basically testing. Do you understand? Do you understand how to do the math? Do you understand to tell, other than it's red? Basically, pretend you can't see colors. That hunter machine's not so easy anymore, is it? ASE is basically taking the colors out of the hunter machine, and it's not giving you an arrow. It's just giving you a number and a range. You got to make the range, and then you say, yeah, that right side's out of spec. If the camber is too far positive, what would that cause? Yeah, that's exactly right. I can show you with the tire right now. Don't ask what happened to this tire. I don't want to tell you. This is mine. So here's your tire. We have, it's on the right side, and it's like this. See, it's going to wear the outer edge. Do you agree? This tire wore pretty good. I wonder who did that right now. Okay. So what's our answer to this question?
It's gonna be both.
We can't. What did we do for before? We can't. It said it's not the only and it's not neither, but now we just confirmed that they're both right, huh? So C. The answer is C. Long question though. I would probably do the other ones first and then come back to that one.